Docker, 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 the Docker, Docker. That's a lot. So let's see if I can do this one right. Docker, 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 microservices. Docker, 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 Docker. And that's my talk. Thank you very much.
No.
Are we ready?
Okay.
Good?
Okay.
Is it working?
Okay.
Okay. All right. Now we're ready to go. I got to take care of it. All right. Sorry. We have T-shirts, and we wanted to make sure that we had T-shirts available to hand out. There are a limited number of T-shirts, but we have somebody going to get them from the location where they're at because we forgot to bring them. As I said, we were doing karaoke last night, so when you sing at a very high volume, you tend to forget things. So the T-shirts are on their way, so catch us later and we'll have T-shirts probably by the time my talk ends, hopefully. My name's Michael Ducey. I work for a company called Chef, but I'm not going to talk about Chef today. I'm actually going to talk about changing the behavior of IT and the way we work in IT. There's my details for Twitter, if you want to connect with me after that, and also a URL for my blog as well. So let's talk a little bit about me, and then we'll talk about changing the behavior of IT. So I worked for a really long time as a Linux engineer. I did a lot of operations work as well for an e-commerce travel site in the US. It's called Orbitz. There's an Asian version of their site called Rates to Go. But in that role, I actually got to wear a lot of hats and do site reliability engineering, and then also some performance and capacity planning. And then I worked for a little while as a cloud architect, working with different cloud platforms. But I've done, for probably the last 5 or 6 years, I've had a big focus on my work in automation and automating things. And that's why I work at Chef, which is an automation framework. I have a Master's of Science degree, but also, oddly enough, for somebody in IT, I have an MBA. Now, that doesn't mean that you should, totally discount everything that I say right away. But it's been kind of an interesting journey for me over the past, 3 or 4 or 5 years. So I decided to get my MBA in 2007, and I finally finished it in 2010, I think, 2011. And the reason why I did it was because as I worked at Orbitz, the travel site, we had these business people that would come in and they would be like, we need to have this right now. So like a good example of it was, so MSN, the MSN.com, the Microsoft portal site, they were going to put our travel site on the front page of MSN. And what this meant was that people could go to MSN and they could type in where they wanted to go, what dates they wanted to go, and do a search, and that would fire back and hit Orbitz's platform, and basically give you search results. And this was huge for us, right? Because it's going to drive a tremendous amount of traffic to our site. So we figured that we needed about 10 WebLogic servers to actually handle this additional traffic. And can anyone guess how long it was going to take to get 10 additional servers up and running? And these were actually bare metal servers at the time, up and running. Shout some numbers at me.
10 minutes with Chef.
10 minutes with Chef. We have a T-shirt for you later. Also 1,000 yen. So 6 weeks, right? And it was 6 weeks, and that was us humping it to get those out. And a lot of it was the approval process that we had to go through. We had to get the actual hardware from our value-added reseller. So, virtualization wasn't as widespread as it is today, so hopefully you could virtualize those hosts, and you wouldn't have to worry about the hardware lead times. But most of that was actually our internal processes that prevented us from getting those machines. And so I thought of this, and it was, a woman who was actually on the keyboard installing WebLogic, right? And doing everything by hand and changing all the settings and going through a checklist, right? And it's just not about Chef, it's about how horrible of a process is that. Because CF Engine was around at the time, right? And I think Puppet was around in its early stages at the time. There's no excuse for us to be on the hands on the keyboard making these changes to deliver something to the business to get revenue for all of us, so that all of us, because everybody had a bonus that was tied to revenue of the company, and the quicker we get those servers, the quicker that we can bring in revenue, the better it is for all of us at the company. But no, 6 weeks to get the servers. So as I did my MBA, I had this epiphany. And so that's why I wanted to go do my MBA, because I wanted to understand business better, because I thought that if I understood business better, I could actually serve the business better, because I understand what they're trying to go through in what they're trying to deliver to the customer. And if I can understand what they're doing better, I can hopefully serve them better. Because at the end of the day, IT is about serving the business, right? We hear it all the time. It's almost become a cliche. So, I should probably start my timer so I know. So I had this epiphany that I needed to go do my MBA to understand the business better. But in doing my MBA, there's a course that almost everybody who goes through the MBA has a survey course on a topic called operations management. And I learned about operations management, and I had this moment of it was my epiphany. I was like this young child and just really excited about what I was hearing. And for those of you who don't know, operations management is an area of management concerned with overseeing, designing, controlling the process of production, and redesigning business operations and the productions of goods and services. So in IT, we're focused on the technology a lot of times, and that's great, right? So we've had great tech talks today about OpenStack and Docker. But what we often don't realize is that we're working with OpenStack, we're working with Docker, we're working with all these different technology items to deliver a service to somebody, right? And to make the company money, right? And so, operations management is this age-old process. You know, it's been around for at least 80 years. A lot of work in operations management was actually done right here in Japan, right, with Toyota, and basically streamlining how we do work and how we manufacture goods and services. So in operations management, there's this idea of how you optimize a production service, right? And by production service, I mean not a service running in production, but a service that is producing something, right? And so here we have what's called a value stream. And this comes out of lean manufacturing. So has anyone ever heard the term lean, right? So most of you should, I hope. So there's this practice called lean, and lean is now going into everything. We have lean enterprise, we have lean IT, we have the lean startup, we have running lean. And there's actually this whole series of books that focus on these principles of lean manufacturing and how we apply them to other areas. So one piece inside of lean manufacturing is this idea of value streams. So we have this idea of a value stream in that I have something coming from a supplier, and this object from the supplier is going to go into receiving, it's going to sit there for 5 days on the loading dock, and then it'll finally go into milling, and it's going to spend 2 minutes in this process right here. And in this 2 minutes, this is when the value is actually added, right? So in this 2 minutes, it's this piece of metal or whatever it is. I think this is like a bike frame manufacturing production line, right? So we're going to mill the metal tubes to get them ready for welding, right? And it's going to be 2 minutes to actually cut those tubes to the length that they need to be. And then we have two people that are actually welding, and it's going to take them 4 minutes to weld this bike frame together. And then it's going to get painted, and it's going to take 7 minutes to do that. And between welding and painting, it sits there for 15 days before anything is done to it again, right? And then after painting, it sets for 8 days, which I guess maybe that's to let the paint dry. I don't know. And then we assemble and inspect the piece, and then we actually ship it off to our customers. But it's 30 days before it actually gets shipped off to our customer. It's just set there doing nothing, right? No value is being added to the process during that time. So I saw this diagram in my operations management class, and I'm like, holy, expletive. Like, we do this all the time in IT, right? Does this look familiar to anyone, right? We have the operating system, we have 2 people installing the operating system, and then we throw it over the wall, right? To the application people, and it sits there for 10 days because, the application people are busy, they have other things they need to do, and when they finally get around to it, they only spend 4 minutes doing what they need to do to install it, or maybe, 4 hours, time doesn't really matter here. Then they throw it over the wall to the database team, and then they throw it over the wall to the security team, and finally at the end of this, we ship it off to our customer, the business, to actually have something useful, to actually provide a service. So this is the idea of lean and value stream mapping, and this is the current state of the way things are. So meanwhile, 5 years ago, in Ghent, about the exact same time that I'm beginning my MBA course, there's this conference in Ghent, in Belgium, and it's called DevOps Days. And people are getting together to talk about how do we change the way we work in IT, and how do we change our behavior so that we don't have garbage like this anymore, so that we can begin to move faster. So, if you think about what we do in IT and the work that we do, right, it's all about flow, right? And so, say this is a series of pipes that I horribly drew. But water is going to flow into this first kind of silo, if you will. And nothing can move over into this silo until this silo is full, right? And so, eventually this silo fills up and starts to spill over into the next silo. And it just continues, right? And if you think about the work that we do, right? You think of how typically we're organized, or at least traditionally how we're organized. This is how our work flows, right? This is how we actually work in many organizations. It's horribly inefficient, right? And it's going to flow, and it's going to flow, and eventually we'll get something useful out the other end, the water that we actually want, right? And it's going to take 6 weeks to deliver that server, right? So what if there was a better way, right? Well, everybody looks at this diagram and they're like, why would you ever connect pipes like that, right? I hope that was the first thing that you thought. It was like, what crazy guy is going to move water that way, right? This is the pipe that you want, right? This is the most efficient way to actually move something through the system, right? To get water from one end to the other end. And if we have lots of pipes all put together, we can actually have a lot of water flowing through the system. And so if you think of how business requirements flow, so let's say if these were business requirements and customer delivery, just like on our value stream map, it's a horribly inefficient way to move business requirements through our system. So think of this as the old traditional way of waterfall, right? And this is obviously why waterfall is bad, because we just flow over it. We've got to wait until we can overflow with what we have until we can move on to the next thing that we need to do. And think of like Agile and Scrum and new development methods, and that's really what it is about pushing work through the system faster, about increasing flow because we're doing smaller pieces of work. And that's this term that we call DevOps, right? So if you haven't heard of the term DevOps, Wikipedia actually has a really good definition of what DevOps is. But there's this practice of bringing development and operations together. And we bring development and operations together to increase the flow of work through our system. And our system is all of us, right? Working together to deliver something to our customer. And the business, it should actually be, dev, biz, ops, or something like that, because the business is included in this as well. So it's just not development and operations, it's the entire organization, right? And so why does this matter? Like, why is this crazy guy from America up here talking about how water should flow, right? That was a joke. You guys are supposed to laugh at that. I'm not actually crazy. So my business partner Arnie always says that I should never joke, like when I'm giving a talk in some place where English isn't the first language. But I still always joke, and of course nobody ever laughs at my joke. That was another joke that you were supposed to laugh. There we go. Now we have the flow going a little bit better with me telling the joke, you laughing, I'll tell another joke. We'll have a good time. So in economics, there's this idea of what's called, or this theory called Jevons Paradox. And we're seeing this today on a really, really big scale. We're seeing this play out. This was written in the 19th century, so the mid-1800s, by this guy in England, and he was actually looking at coal consumption, and they didn't understand why coal consumption was going through the roof. And the reason why coal consumption was going through the roof is that they had invented new mining technology to actually get coal out of mines better and faster. And also in the 1800s, what happened? We got trains, right? So we could begin to move coal faster. We could get it out of the ground faster. We'd put it on a train, and we'd get it to the consumer faster. And thus what ends up happening is we consume more of it because we can get it easier and we can get it quicker, right? So this is the basic idea of Jevons Paradox. And basically this economist, I'm sure he probably wasn't considered an economist at the time, but he's an economist now to us, basically studied this and then realized that the demand was elastic. And when you make something easier to consume and easier to use, you actually use more of it. And the paradox is usually when you think that if you flood the market with a bunch of supply, demand doesn't always match that, and so you have to have supply and demand meet each other, right? Otherwise, we're just wasting our resources creating a bunch of stuff that people don't want. But the paradox is that if we actually make it easier and better and cheaper to use, on some things, people tend to use more of. Sound like anything we know? Does it sound like compute, right? So what happened in, around 2007, and actually a little bit before that when virtualization really started to take hold, and then 2007 and 2008, when companies like Amazon made cloud computing very popular, we have this huge spike in the amount of consumption of compute, right? We made compute easier, cheaper, and faster to use and consume, and thus we're consuming more of it. I mean, we can't walk down the street anymore without consuming compute, right? Whether if we're looking at our map or we're looking at the train schedule or something like that, right? We're consuming more and more and more of it. And so what's ended up happening is the traditional model, because we need to consume compute more and more and more to deliver services to our customers, because what they expect nowadays is this experience, right? And as the keynote mentioned, with now everything's going to be connected to the internet, so we're going to consume compute more and more and more. Current methods just can't keep up, right? So what do we do? So let's shift for a second away from the delivery side or the operations side of things, and let's talk about what was happening at the exact same time, or roughly about the exact same time that Amazon was getting popular. Let's talk about what was happening in the world of development, right? So in the world of development, this was no longer the way we wanted to work anymore in development. We didn't want to work this way in development anymore because it was slow, it was fraught with error and problems, right? So about the exact same time that cloud computing started getting popular, these ideas started getting more popular as well and more accepted. And so Agile and Scrum has kind of taken the same principles of Agile and turned it into a certification that you can buy for $99.95. That's a joke again as well. Yeah. Come on, work with me, guys. And gals. And then the other thing that happened is this old idea of test-driven development has begun to get, at the exact same time, started to get extremely popular as well. And the whole idea of test-driven development, for the people that aren't familiar with the idea, is that the first thing I do is I write my tests, right? So typically, when we're developing code, well, when I was taught to develop code, we wrote the code, right? And did it work? It doesn't compile, I missed a semicolon, I did whatever. And then I would go back and I would fix my problems. And then I would, put some things in and see, does it work the way I want it to? Does it, no? All right, we'll go back and fix it. Well, the idea is that we actually begin to write tests first, right? So we know what we want from an input perspective, we know what we want from an output perspective. So write a test to make sure that that code actually works the way we expect it to. And of course, when you're first writing your code, you have no code, and thus it's going to fail, because your test won't work if there's no code to actually execute. I hope everyone understands that concept of computer science. And then what we got to do is we actually got to write the code to make the test work, right? So we put testing at the front of things, and we verify before we actually begin writing anything. We're verifying, are we getting what we want? And then once we make our test green, then we go and we refactor our code, right? And we make it more optimal, right? And then we just continue through this loop. And hopefully after this you commit the code up and you verify that it does what you expect it to do, and our commit process gets faster, right? So what's happened is that we've increased the velocity that developers, through Agile and test-driven development and other changes that the way developers began to change the way they worked, we began to increase the velocity of work that we're trying to push through the system. And the business people are like, this is amazing, right? I can push code all day long and get lots of code out, right? But of course we know that's not what really happened, right? What really happened was there was this perfect storm, and there continues to be this perfect storm throughout the world, right? Because everybody is not adopting Agile at the same rate as the US adopted Agile or cloud computing, right? And so what we're seeing is there's this perfect storm where development and development and cloud computing are putting pressures. So this is called externalities. So there are these externalities on operations needing to change the way they work and the way that they behave. Because on one side they've got development throwing code very quickly at them and push, why can't you push faster? I need to go faster. And then cheap, easy, accessible compute that can be consumed very quickly is on the other side. And development's like, what am I going to do? You guys can't move fast enough, right? And so what does development do but create shadow IT? And so the idea of shadow IT is that operations isn't able to keep up, so developers take their credit card, they go to Amazon or Azure or whatever, they put their credit card in, and they I got compute all day long, right? I get everything I want as fast as I possibly can, and forget the operations people because they're just not moving fast enough. I just realized I've got a joke. I can see my next slide, and it's probably not going to go over very well. So let's see if we can do this. It's a play on French. So hopefully there's some French-speaking people in the room. It also creates rogue IT. Oh, that's rouge IT, which rouge is red in French. Thank you. I went through these slides earlier and I'm like, is there anything I need to remove? Is there anything I need to remove? And we're like, oh, that's a funny joke, I should leave it. But it creates rogue IT, right? And now we've got these people that are going and working and circumventing the process, right? And we call them rogues, right? And rogue is a dishonest or unprincipled person. And just because I went to Amazon and put my credit card in and I needed compute power because you're not fast enough, I'm not a dishonest and unprincipled person. I just got to get my code out, right, to serve my customer to make the business money, right? So I looked up rogue for this talk, and I put in the noun definition, but I learned a new definition that I didn't know before. There's another definition, which is removing inferior or defective plants or seedlings from a crop. And so it is rogue IT because they're removing the defective parts of IT and just going right to Amazon or Azure or whoever and getting the compute power that they need so they can move fast. So this has created a little bit of a conundrum, right, inside of IT, right? Because one team's not moving fast enough and everybody else is. And really, if you think about how we work and how we've been behaving in IT, at least in the operations side of things, this is kind of the old traditional way of doing things, right? So we receive a request, and this is the operations workflow. We build some scripting, maybe we test, maybe we don't, because our staging environment isn't the same as our production environment. So we really can't test in staging to make sure that this particular change is going to work. I submit the change. I go to the change advisory board. Usually I do some social engineering in the change advisory board because I really want this to go through, and I have friends on the change advisory board and I can manipulate them, or I can offer to buy them beer or something like that, or maybe a nice thing of whiskey, and I can get my change through. And then I go and I actually execute my change. If there's errors, I'll fix them, and then I finally close my change, right? So we've created this gate with the change advisory board. Does everyone have a change advisory board where they work? No? Good. The people are shaking their head. But this is the kind of the old way that we do things and the way we worked. And so we had operations following this way, and we have development following this way, right? We're checking out the code, we develop, we unit test, we test locally, we commit the change, we test in dev. We do a code review. Somebody says, yep, that looks good, makes sense, we're not going to break anything. Oh, no, that doesn't meet our standard, go back and fix this thing. We merge the change, we test some more, we promote and we verify. In a lot of cases in development, this is all automated, right? So think of things like Jenkins, right, where we can automatically do this integration testing ahead of time, and we can know with confidence that I can actually merge this change, at least a greater degree of confidence. Yes, Jenkins isn't perfect, and integration, continuous integration isn't perfect, but it's better than what we had before, right? And we have a higher degree of certainty that things are going to work. And so we have traditional ITIL processes. If you're not familiar with ITIL, it's something called the IT Infrastructure Library. It came from the British government. Why would you take anything from the British government and make it a standard? I'm not sure. Or any governmental body. Sorry to the people in the government from the room. Please don't have me removed from Japan. I love this country. But it's basically, it's how we should work, right? And how we should behave. We should have change management. We should have incident management. We should have all of these processes and controls to reduce risk and be safe. And you need to stop and not move fast because moving fast is risky, right? And so there's none of this idea of test-driven development when we're going through this process. We're not verifying. There's no feedback loops to actually make sure that one person is doing something and you're telling the other person what you're doing, and you basically have this communication path going on. It's disjointed from the way that we work in other parts of the organization, so it's not the same way that we work in development. Operations works in a completely different way. And it's focused on tasks. I just need to execute things. I just need to execute tasks. It's not about maintaining the state of the system and the state of the way infrastructure is defined. And so the idea is that there's a better way forward, right? So what if development and operations could actually work in the exact same way? And so what we've been seeing is this idea that we can actually change, and operations can change and work almost in the exact same way that development can. And so what if we could put in testing and verification at each step? What if we could have feedback loops where, as an operations person, I have somebody reviewing my code, right? What if we have like success fail, right? So I have my own testing that's telling me if things are working correct before I push. And this is one of the things that's really appealing about Docker, is that I can have this consistent environment that moves through my life cycle, this consistent container that's the same in my life cycle in the early stages as it is in the late stages, right? And thus, when we do that, we have this consistency. We can have changes that I know, like anybody ever changed something in production and you know that change never got made in staging or testing, and then staging and testing is broken, and we don't know why, and then we finally discovered, oh, somebody changed something in production, and we don't put it back in the place in staging and production, or staging and test, and then everything's broken, what the heck's going on? Well, in this world, in this different way that we're working now, and we can work with Docker and infrastructure as code and Chef and Puppet and so forth, the changes can begin in the lower environment and automatically move into production when we're ready to. And its focus is on what's called maintaining the state of the system. So when we define, we have this idea that we can define the way our infrastructure looks in this abstraction. I can actually then, I'm managing the state. I'm not performing actions anymore, right? And this is kind of a different concept than we've been used to in operations. And the really interesting thing is that it leverages the software development lifecycle. So basically what ends up happening is that I have all this history of the way that we've been working in software engineering, and I can take this exact same thing and move it into operations. These next two are kind of interesting because it eases the compliance burden, right? So we have to prove a lot of times that are we auditing? Are we actually making sure that there's separation of duties? Am I checking somebody else's work? Are things secure? Are we meeting our standards and various things like that, right? Well, when we begin to change the way operations work and they work like development, there's a consistency that eases being able to actually prove that we're making our audits and everything like that successfully, right? And we're showing that we have controls in place. And really what it does is, when we think of the old way that we worked before, where we're putting in gates and checks and things that we have to stop to control risk and control security and not move fast, slowing down things, those are bolted on process after the fact to solve the problem that we're working wrong in the first place. But if we work the correct way in this new world, the process is actually built in. So I'm putting my checks as part of the work that I do normally, not as something we put on after the fact to say, hey, stop, and slow us down. So there's this idea in DevOps, and something that's getting extremely popular is there's this 5 core tenets, and these 5 core tenets in the world of DevOps is collaboration, so sharing, like we're doing right now, right? So, great conference, thanks for having me, and thanks for everybody coming out. Because what this is all of us collaborating. It's making everybody better, right? It's a huge technology company, or a huge company here, and they're sharing their technology openly and freely in many ways. And they're doing it to make you better, and this is happening the world over, right? So there's a huge conference in San Francisco last week where everybody's getting up and talking about, banks, retailers, and so forth are talking about what they're doing with technology, and say, hey, let's make everyone better. And so collaboration is a key tenet of this new way that we're beginning to work. Lean, so taking the principles and practices that came out of the Toyota production system and the way that we manufacture cars here in Japan, and the way we tried to manufacture cars in America, but it took us about 30 years to actually change, to begin to manufacture cars like Toyota manufactured cars. And Toyota actually had executives from American car companies come over and say, hey, you should work like this. Look how we do it. We build really reliable cars that are safe and great cars. And you should manufacture cars the exact same way. In America, what did we do? Like, no, we're going to keep building cars the way we've always built cars. And of course, our cars are pieces of junk, right? They've gotten better. But I don't think they match the quality of Japanese cars, right? I own a Toyota. And so it's basically rethinking the way that we're working and actually applying these principles in Lean that actually came out of Toyota. It's automating, so everything should be automated. If it's not automated, it should be considered a bug in the system, right? We need to automate, automate, automate. The reason why do we automate? Well, because these right here are bad, right? These make mistakes. If I automate, I know that everything is being done in a consistent manner over and over and over again every single time. With these, my fingers, that's what I'm trying to point out here. You know, like we saw in the demonstration, right? I typed address with 1 D instead of 2 Ds, and now the production systems are broke. Right? Anybody ever do that? And then it's measuring, right? So like you can't get better if you don't measure what you're actually doing, right? So how do I know that I'm actually getting stronger if I'm a runner, right? Is it by the number of miles that I do every week? Well, that's part of it, right? But I have other measurements that I can actually take that actually proves my fitness is actually getting better. Like my body mass index is actually means I'm getting fitter. My height to weight ratio is better, right? The amount of oxygen my body can burn it's called VO2 max, right? So that's another area that actually proves that I'm getting fitter and better. And if I don't measure those things, as a runner, I'm just running, right? And then it's sharing. So actually, this is supposed to be culture, not collaboration. I always change it and make it collaboration, but it's culture. So it's changing the culture, and sharing and collaboration kind of go together, so I always confuse the two. So sharing like we're doing now, culture is actually changing the culture. So like I mentioned about the reason why Chevy and Ford couldn't actually change is because their culture didn't allow them to actually change and adopt the Toyota production system, right? And so Toyota's like, yeah, come on in. We'll show you everything that we're doing. We'll share with you as much as possible. But they knew Chevy wasn't going to actually be able to do anything and actually steal their technology until they actually changed the culture of Chevy. And once Chevy actually changed their culture, they were actually able to do a lot more and get a lot better. And so let's talk about Lean and Agile and how Lean and Agile kind of applies to the way that we're changing IT. So operation sprints. So operations are beginning to work a lot like developers work. So we do small batches of work, and we can move much quicker when we're doing small batches of work. And if that small batch of work, so instead of doing a huge release, we do a small release, and if that small release breaks, it's much easier to know exactly what braked, and it's much easier for me to roll that back. We're using things like Kanban. So anybody familiar in the room with Kanban? It's a little bit of a joke. So Kanban is actually a Japanese term. So Kanban is basically where I can take, I'm using cards to move, I can visualize my work, and if I can visualize my work, I can actually move my work through the system faster. Another example of Kanban is when the Imperial Gardens are opened up and you can go into the Imperial Gardens, they give you a little token, right? They give you a little chip, and they know at any point in time how many people are inside of the Imperial Gardens, right? Because they're visualizing it with these little chips, and the people in the token booth, they can look and see, and they say, I can let 10 more people in. And if I have 500 chips, I've got 10 left, I've got 490 in there. And when you leave, you give the chip back, and it's like, oh, I have 498 now, right? So it's visualizing the way we work, and when we visualize the way we work, we can actually begin to move faster. So I already talked about small batches, but then it's also being able to test, right? So A/B testing. So this idea that if I can dynamically create my environments very quickly through something like Docker or Chef or Puppet and Cloud, I can then begin to test to make sure things actually work. If it works, good, this is my new production system, I'll destroy everything else, right? And thus I can roll code out with greater reliability and greater knowledge, knowing that things are actually going to work. But there's a lot of advice out there, right, of how do we change the way IT works. But the most important thing is two important ideas, and then the last 2 minutes that I have left, is whatever works for you, right? So we're hung up about like how everybody else thinks we should work, but what we really need to focus on is I need to do what works for me, and you guys need to do what works for you so that you can actually be successful with what you do, right? So advice is great, but realize what works best for you as well. And kind of the corollary to that is that assume everything that you've been doing is wrong, right? So we have this really hang up where we focus on, well, this is the way that we've always been doing it. So my final thought is, there's this old parable of this guru who would go and meditate. And every time he would meditate, the cat would bother him. A cat would bother him and get on his lap, and he's trying to meditate and he can't do it if the cat's bothering him, right? And so he takes the cat and he ties the cat to the tree. And then he goes and he meditates. And the guru begins to get followers, right? And the followers see that we tie the cat to the tree when we meditate. Eventually the guru dies, and several hundred years later his movement is still going. And every time we go and we meditate, the followers continue to tie the cat to the tree. And one day, one of the new followers says, "Why do we tie the cat to the tree?" And the people who are running, doing it now, they basically say, "Well, because that's what we've always done." And they had no reason and no idea why we actually tied cats to the tree every time we meditate anymore. So when we think about the way we work and the way we behave, you need to think, maybe I'm not doing things correctly, right? And understand sometimes why we were doing things in the past and realize that the world has probably changed. And with that, thank you very much. Thank you for having me.